Okay, good morning everybody, Chris Young here, welcome back to N3 Chemistry. Today's video will include a quick review of rates, then we'll be talking about salt solutions, then atoms, elements, compounds, things like that. We'll be talking about how to separate different mixtures and different compounds, and we'll be talking about things like filtration, evaporation, distillation. A slight aside about Prestonpans, which is a small town on the coast near Edinburgh, and then we'll be talking about what we've talked about. Okay, so let's get started. So a quick review of rates then. We're looking at how different factors can affect the rate of a chemical reaction. For example, if I remember rightly, there was heat. If you add heat to a reaction, it'll happen quicker. Surface area, increase the surface area, so like using powder instead of chunks. What else? We've got adding a catalyst can help to speed up a reaction. And the fourth one was the concentration of the acid or the substance that you're using for the reaction. All of these things can increase the rate of a reaction. They all get to the same end point, but the faster the reaction, the steeper the curve, and the sooner they reach that end point. And you can measure the rate of reaction by different ways. For example, how much gas is produced and also how much mass the substance decreases by. Okay, so that's what we did last time. Let's start today talking about salt solutions. Now, salt, I'm sure you're aware, is sodium chloride. It's made up of two different elements. Sodium, which is a very reactive element, and chlorine, which is also a very reactive element. You add them together, boom, they create sodium chloride, which is a compound. Okay, now elements and compounds are made up of atoms. So I've got here a bit of Lego. I hope you can see that. There we go. And in classic Lego, the smallest bit that you can get is a 1x1, isn't it? It's a 1x1. Oh, there's a 1x1, right? So that's the basic building block for Lego. You can't really get any smaller than that. Well, you can now because you got all these other little things, but in the old days this was the smallest you could get. And this is basically what an atom is. It's the fundamental building block of substances, okay, of things, of stuff, of nature. Now this could be broken down to even smaller pieces. You could probably take a hacksaw to this or a hammer and smash it up into smaller bits. But we will look at those bits in another video. And different elements are different types of atoms. They might be different, well, they'll have different characteristics, okay? So some of these atoms can join together to make a compound of the same substance, the same atom. Or you can have two atoms from different elements joining together to form a different compound. Okay, for example, sodium chloride. Now, sodium chloride is your average everyday salt. Now, if you put that in water and mix it around, I'm not going to put Lego in a glass of water. Well, I was tempted to, but I might be drinking this later, so I'm not going to do that. And it won't dissolve anyway, because salt, if you put salt in water and stir it, the salt will disappear. It will dissolve into the water. Okay? In that case, the salt is called the solute, right? The solute. The water is called the solvent. Solvent. Okay? Solute, solvent, and after you've put the salt in the water and stirred it around, this is a salt water solution. Okay, so these words are very important to remember. Now, if you put more and more and more salt into your salt water, eventually no more will be dissolved. In that case, we will say that the salt water has become saturated. Alright, there's too much salt, it can't take it anymore, it's saturated. Now, how do you separate the salt from the water once it's in there? how do you get the salt back out again? Well, we'll be looking at that method, which is called evaporation. You heat up the salt water, and the water evaporates at 100 degrees, changes to gas, drifts away, leaving the salt in the glass or the container. Now maybe you've been in a situation where you've worn trainers a lot and done a lot of sport, and then you've gone out and you've walked around, and your shoes dry off, and you look down, you've got white crystals on the outside of your trainers, because that's actually salt from your sweat, or from salt water if you've been walking on the beach or whatever. So that's evaporation. Now, I was also going to talk a little bit about separating mixtures. Now, salt water is a mixture. Salt is dissolved in the water, it's mixed together with the water, right? But it's not a compound. Salt water is not a compound. Sodium chloride is a compound, but salt water is a mixture. So it's easier to separate mixtures than compounds. But you can, well, let's look at another example. Let's look at iron sulfide. Now, if you've got iron, which is little metal filaments, and you've got sulfur, which is a powder, mix them together, how do you think you can separate them? Well, we can separate them using a magnet. It's quite easy. You hold a magnet over the substance, and all of the iron filings leap out of the mixture and join onto the magnet, leaving the sulfur. But if you have a mixture of iron and sulfur and you heat it, then the iron and the sulfur will join together to form a new compound, iron sulfide. And it's harder to separate after that. You can separate compounds. For example, copper chloride. Copper chloride is a kind of a bluish liquid, and we can use a technique called electrolysis, whereby you put two electrodes into the liquid, connect up a battery, pass electricity through it, and the copper will go to one end, and the chloride will go to the other end. And I can't remember which goes to which end. It's going to be a case of positive and negative, probably. Doesn't say. Oh, the green chlorine gas is formed at one end of the carbon rods, and the brown copper solid forms on the other. Okay. So that's good to know. It is possible to separate compounds into its basic atoms. So we've talked a bit about evaporation. Let's talk about filtration. Filtration is when you separate a mixture of liquid and solid, and the solid hasn't dissolved in the liquid. For example, let's say you've got sand in your water. You want to get your sand out. All you do is pass it through some filter paper. Or more modernly, if you've got a coffee, maybe you make coffee every morning. Now the coffee bean is an interesting bean. It's one of my favourite beans of a morning, but not all of the coffee bean is soluble. So you need some filter paper to separate the soluble coffee bean, which has gone into the hot water. You want to get that through, but you use a filter paper to catch the insoluble leftover sections of the coffee bean that you don't want to get stuck in your teeth or crunch between your molars, because it's not that pleasant. So that's filtration for you. Filtration is also used with reservoirs to filter the water, because the water's got like bits of fish and seaweed and sand, and you don't want to drink that. You don't want to turn your tap and get all that stuff coming out. So what they use is things called filtration beds, which are layers of big pebbles, small pebbles, sand, and then I don't know what the final layer would be. Maybe some kind of filter paper, and then that filters out all of the rubbish from the water, makes it more pure. And you can probably make your own filtration system using a plastic bottle. You cut it in half, so you've got it looks like a funnel, and then you can probably put a bit of cloth in the bottom part, and then sand, small pebbles, bigger pebbles, and then turn the cap off, put dirty water through, and then it should be cleaner when it comes out the other end. I don't know how clean, but I don't know. I don't recommend that you take a dirty puddle and filter it through something like that, because there might be other things like bacteria which might go through with the water. So after you filter it, it might be a good idea to boil it, just in case there's any living organisms. Okay, let's talk about distillation. Now, distillation uses the process of evaporation with different substances. Alright, so let's say you want to separate water and alcohol. Now, alcohol has a lower boiling point than water. So if you boil a mixture of, or if you heat a mixture of water and alcohol, then say you get, I don't know what it is, so say you get to 80 degrees or 85 degrees, then the alcohol will start to change to gas and drift off and drift away. And maybe you can capture that in another tube. The water will stay there though, because it hasn't reached 100 yet. So the alcohol is in gaseous form. It goes through another tube, which maybe is cooled with cold tap water. So then it condenses, it changes back to liquid, and it can drip down into another little container, maybe. And then you've got your alcohol. And that's how a whiskey is made. And it's also how we get different kinds of fuel from crude oil. Because when crude oil comes out of the ground, this is nasty, thick sludge, and you want to separate it into different qualities of oil using distillation, because different kinds of oil have different boiling points. So you can kind of peel them off that way. Okay, we've got a little bit of time left. I just want to quickly talk about Prestonpans, because Prestonpans has become my new favourite seaside town in East Lothian, just next to Edinburgh there. You've heard about the Battle of Prestonpans, but have you heard about the pans of Prestonpans? Back in the 12th century, monks used to use big pans to store seawater, and then the seawater would evaporate in the sun, leaving salt behind. So that by the 16th century, those crafty monks were producing 11 tons of salt per week and exporting it, probably selling it to get money to buy Buckfast. Only joking. That's a joke. I don't know. I'm not up on my Buckfast lore, but that's quite a lot of salt, and it's very inventive. And that's where the pans and Prestonpans come from. And Preston comes from the word priest. So priest pans, priestly pans. That's where Prestonpans gets its name. So I think that's a good place to finish. I've rattled through this. I hope it hasn't been too painful for you. What we did today was we reviewed rates. We talked about salt solutions. We talked about atoms, elements, compounds, Lego, iron and sulfur, separating them as a mixture versus the compound iron sulfide, and then copper chloride, which is the liquid, and you've got the graphic rods, and you've got the electricity, and the copper, and the chlorine, and the filtration, evaporation, distillation, different methods of filtering substances. And then we talked about Prestonpans, and that's it. Thank you very much. Goodbye. Hiya. Yes.